Welcome back to the final installment on linear inequalities and graphs. As you may have already guessed from the title, it's a diagnostic test. As always, I recommend you to pause the video for each problem, work it out, and continue watching to see if you got it right. If you did, well done, kudos to you. If you got it wrong, don't pause the video, just continue doing the next problem. But before you do the next problem, make a note in your notebook or whatever you're working with. Why did you get something wrong? You need to know, because if you don't fix that area that you're specifically lagging, no matter how many times you encounter that problem, you're not going to get it right. So make a note in your own words on area or areas that you were either lagging or having doubts or unsure, which is what led you to get that question wrong. Make a note of it, go to the second problem, and do the same process until you're done with the test. If you got all questions right, please comment in the description box below whether the previous videos were particularly helpful or whether the content as a whole was helpful in you achieving a perfect score. Okay, if you didn't, then you are welcome to share your experience in the process, right? So without further delay, let's get started. The first two problems, you're given a statement and you're expected to convert that statement into an algebraic expression containing an inequality, right? So the first part of the statement is very easy. It says sum of 120K and 215J. So all you have to do is just add the two terms. Now, that in itself is not giving away the opportunity to eliminate any of the choices. But it's only the second part that actually has as what you need, does not exceed. That means this whole thing can have a maximum value of 2500 or below. That means it's less than or equal to 2500. Here's a little bit of tip and tricks here. When you see words like does not exceed, okay, at least, at most, when you have this sort of words, depending on the context, you can either have a less than equal to or greater than or equal to, depending on how it's framed, or one keyword could specifically be for less than equal to or greater than equal to. But the point here is there's an equal symbol appearing. It's not just greater or less than, it has to have an equal symbol. That is, it's greater than equal to or less than equal to, right? So we can add more keywords as we do more problems, but in this case does not exceed definitely fits into the less than equal, because it's saying it can only have a maximum of 2500 or somewhere below depending on the value of K and J. So you can right away eliminate choices A and B because they do not fit the criteria of an equality in the inequality. So you can only be C or D. C is a perfect match for what we have written. D is exact opposite of what we want, so that's incorrect as well. Hence, A1 in C is the correct answer. The second problem, 1/2 a number is decreased by 3. So n over 2 is decreased by 3. So right away we can eliminate choices B and D because it's the opposite of it. It didn't say 3 is decreased by 1/2 of a number. So you need to know how to decode these things in your mind, and a lot of it comes down to practice. Of course, you have to watch the video and learn the content and start applying. You can also randomly search problems on the internet for these type of areas and then just work it out using the knowledge you gain from my video and then see if you get it right. If you get it right, do a couple more. And if you still get it right, then maybe you're confident. You don't need to do that area again. But you have to work it out until you do X number of problems and you get them right every single time, right? And this combination is at most -5. That means it can again have a maximum value of -5 or less, right? So it's again at most is in the context here should include an equal. So between these two, you can eliminate C as well because that's only at most means it can have -5 as well, but somewhere below as well. Okay. Don't think most as greater. Then there is no answer choice in this case, luckily for you, that even if you're thinking in that case, Good for you that there is no answer choice here. Had they made this into greater than equal, then it really gives you a difficult conundrum where you're deciding between A and C. But they made your life easy by just leaving it as just less than, which does not fit the criteria here. So hence A is the correct answer. You see, I have a course of action. I don't just blindly do the problem. I figure out what are the keywords, what is that I'm looking for, and then eliminate choices and then narrow it down to one or two, and then I pick my answer based on my expression of what I have, right? All right, which of the following number is not a solution to the inequality? First thing you have to do is to simplify this complex expression. It may not be complex to some of you, but it is to me. So what you can do is first start multiplying by -2 on both sides, which would give you 3b plus 5. Now remember, you're multiplying or dividing by a negative. In this case, you are multiplying. You have to invert the sign of the inequality. So it's -2 times b minus 8. So it's 3b plus 5. Expand this -2 to the expression. So it's 16. So if you add plus 2b on both sides, then it becomes 5b plus 5 less than or equal to 16. Let's subtract -5 on both sides, which 5b is 11, right? And b is you divide by 5 on both sides, b is less than 11 over 5. And 11 over 5, I believe, is somewhere around 2 point something, 2.2 maybe. 2.2. So b is less than or equal to 2.2. So b can have values of 2.2, maybe 2, maybe 1, 0, -1, and so on, right? So 3 out of these 4 values are captured by what I have written right here, 2, 1, and 0. So 3 is out of question because the maximum of b can even have is 2.2. So 3 is not going to be an option. So that is the correct answer. You see, from start to finish, from where I started, and this is where I finished, everything was scripted and structured, and I went through a flow without really taking a shortcut anywhere, right? So if you do that, you're also likely going to get it right every single time. Now, which of the following inequalities is equivalent to this? So all you have to simply do is work your way through the problem, simplify it further, and then you will be done. So here we have 0.6k. 7 times 6 is, what is it, 42, right? So it's 4.2 minus 0.3k greater than 1.8 plus 0.9k. So you can first subtract this 0.3k minus 4.2 greater than 1.8 plus 0.9k. So you can do 2 things. You can subtract 0.3k on both sides, right? Right? So that'll give you what, -4.2 greater than 1.8 plus 0.6k, right? You can add -1.8 on both sides, right? That will give you -6, right? -6 greater than 0.6k, right? So you can divide by 6 on both sides, right? 6 by 0.6, I think. That's 10, right? So -10 greater than k. In other words, -10 greater than k. In other words, k is less than -10, right? That's correct. You see, again, I didn't take any shortcuts. I did my best to not skip any step. Even if it means it's an extra 10 seconds, I didn't skip on it. I went through and completed the problem. All right. Which of the following number is a solution to the compound inequality above? These are 2 separate components. You don't need to combine them under any circumstances. So let's go ahead and solve the first part first. You have to simplify it. So you have, this is what you have. You have to simplify it as 4m minus 3 less than 2m plus 2. You can subtract 2m on both sides, which would give you 2m minus 3 less than or equal to 2. You can add plus 3 on both sides, 2m less than or equal to 5, m less than or equal to, you can divide by 2 on both sides, so m is less than equal to 2.5. It says r, right? So only one of this inequality will contain the answer. We don't know what it is. You have to figure out the second one as well. Now, all of these answer choices would be different had it been an and, okay? So 7m plus 23 less than 15 plus 9m. So we can subtract 7m on both sides, which would give you 23 less than 15 plus 2m. We can subtract negative 15 on both sides, which is 8 less than 2m, or you can divide by 2 on both sides, 4 less than m, right? So, or in other words, m is greater than 4. So, m is greater than 4, right? And m is less than or equal to 2.5, right? So, there's really two answers possible, right? M is less than 2.5. Well, yes, let's write it actually. M is greater than 4 and it's less than or equal to 2.5. What are the values existing between, well, these are two separate things, right? So M is greater than 4, which means 5 can be a solution. M is not 4 for sure. M is less than or equal to 2.5. That means 2 is possible. 3 and 4 are quoted. So which are the following numbers? It's 2 or 5. Right? You can combine these because this doesn't make any sense, right? But I wrote it just so you can see that it doesn't make any sense. M can be 5 or M can be, M is less than 2.5, so it's 2, 1, 0, negative 1, negative 2, etc. So 2 of these numbers are possible, and that's what R stands for as well. I said 2 or 5, just like R here. Okay. All right, we've done some inequalities in the previous video using graphing. So whenever you're given a figure and it's already shaded, it's best to pick a value within the shade. We cannot pick any lines on in the boundary, so it has to be a different point. Before you do that, you need to figure out the slope, because we want the slope intercept form before you can even figure out what's happening. So we have 0, 3 and negative 4, 0, right? This is x1, y1, x2, y2. So slope equals y2 minus y1 over x2 minus x1. So it's 0 minus 3 over negative 4 minus negative 0. It's negative 3 over negative 4 is 3 over 4, right? So y equals mx plus c. So y equals 3/4 x plus c, right? We can use one of the two ordered pairs. Let's just use 0 and 3. If you do that, y equals 4, right? If you put y equals 3 and x equals 0, then c equals 3, right? So the slope intercept form is y equals 3/4 x plus 3, right? If you multiply by 4 throughout, then you get 4y equals 3x plus 12, 4y minus 3x equals 12. Now the question is it greater or lesser? We can still eliminate this, right? So because this is, well, you can do one thing for sure. You can eliminate, it's 4y minus 3x. So it cannot be 3y minus 4x. So these two are out of question, right? So let's take 4y minus 3x greater than 12, 4y minus 3x less than 12. And I said you cannot pick a point on the boundary line. You can pick, say, 0, 4 or 0, 5, okay? To solve for this. So if you pick 0, 4 to determine whether the statement is true for this or this, then y is 4. So 16 minus 0 is greater than 12. That's a true statement, right? Right? So let's apply the same here. So 16 minus 0 is less than 12. 16 is not less than 12. And so it's greater than 12. Now say you forgot the step on a test. So the correct answer is greater than 12. Now, if you notice, this is the origin, right? You see that it is above the origin. So you can roughly estimate it has to be greater than 12. Because it's not less than the origin, you can safely say it's not less than 12. But again, you are gambling. There could be a loophole that you may miss and you may end up getting it wrong. But if you're completely out of options, you didn't know what to do, just think it's above, so it has to be greater. If it's below, it's less. Does that make sense? All right, we've done a similar problem. So let's choose, we have 2y minus 3x equals 6, y equals 1 minus x, right? Right? Or you can even retain the inequality as it is. So you can just say less than or equal to and greater, okay? Doesn't matter. So for section A, let's choose 0, 3, 0. Section B, let's choose 0, 3. Section C, let's choose negative 3, 0. And section D, let's choose 0, negative 3, right? We have to apply these ordered pairs in each of the two expressions and see under which case of ordered pair you get both true statements. Let's just substitute 3, 0. If you end up getting a true statement right away for both, chances are that's going to be your answer. But they also say section or sections. So maybe they were hoping more than one choice, but I can assure you to save time, there is only one correct answer here. So let's substitute 3, 0 here. So 3, 0 means this is your x, this is your y. That means if I substitute that into 2y minus 3x less than equal to 0, that is essentially 0 minus 3, 0, times 3 is negative, less than or equal to 6. It's definitely less than 6, so that's a true statement. Similarly, y greater than 1 minus x, y is 0 greater than 1 minus 3, which is 0 greater than negative 2. That's a true statement as well. So two true statements, section A is correct. While on a test, you still have to go through B, C, and D to determine if they are true as well. And if they're not, then only A is the sole answer. But I have worked this problem and I know for sure there's only one answer available despite the fact they say section or sections. So the correct answer is A or section A. Okay. How do we do this? Again, when we did this sort of problem, we just equated x equals 3, y equals negative 1, right? X equals 3 means y equals 0. Y equals negative 1 means x equals 0. So on the quadrant, let's redraw that. So we have origin 0, 0. Y equals 0, x equals 3 means, how do you do that? So it will have to be something like this, right? Again, it's a greater than or equal to, so you have to draw a solid line. So if you assume this is 3, then x equals 3, y equals 0. This is a solid line. This is nothing but 3 greater than or equal to x. That's what this corresponds to. And then you have y equals negative 1, means if you say this is negative 1, this is a less than or equal to. So again, that has to be a solid line as well. So this corresponds to minus 1 less than y, right? If you notice, neither of these run through the origin. So we can take x equals 0, y equals 0 to test our hypothesis. So if you substitute 3 greater than 0, that's a true statement. And negative 1 is less than or equal to 0. That's a true statement as well. Because it is captured in the origin, you have to subtract, you have to shade all 4 quadrants. Or when you shade, you see you have quadrant 2, quadrant 1, quadrant 3, quadrant 4, all are captured. So the answer is all 4 quadrants contain solutions. All right, this is a very easy problem. You're already given an ordered pair, which makes life easy. So let's go ahead and write those inequalities first. We know the ordered pair is 1, 0. That means this is x, this is y. So let's go ahead and substitute this ordered pair into each of these expression. 0 less than a x plus 1, so a plus 1. If you add negative 1 on both sides, it's negative 1 is less than a, or a greater than negative 1. We were able to achieve that, so option 1 is true. Similarly, let's substitute this into the second expression. So 0 greater than b minus 1. Let's add plus 1 on both sides, which would give you 1 greater than b, or in other words, b is less than 1. So option 3 is correct as well, right? Now, a plus b equals 0. We don't know specifically what is the value, right? We don't know a specific value of a. A is greater than negative 1. That means a can be 0, 1, 2, 3, 4, etc. B is less than 1. That means b can be 0, negative 1, negative 2, negative 3. We may have a case where if you have 2 and negative 2, then you get a 0. But what if it's 3 and negative 2? You're not going to get 0. So because we don't know which value a or b can take, option 2 is incorrect. So it's only 1 and 3. That means it's option C. Does that make sense? It's straightforward. All right, we're cut down to the last 3 problems. What you could do for this one is, for time being, assume it to be just equal, and then you can later add the greater than equal. That's what I found it easy, because essentially that's what we are doing. So we can bring, so let's do it this way. Y minus 12x equals, I'm just shuffling terms. So y plus 6x equals 300. What if we multiply this equation by 2 so we can get rid of the x? So it's y minus 12x equals 600. Y plus 2y plus 12x equals 1 is 330, right? Sorry, this is 330. So this has to be 660, right? So we simply add it. So 3y equals 660 plus 600. That's 1260, right? That divided by 3 is 420. So y equals 420. Simply get rid of the equal sign and add the greater than equal to that appeared in both the expressions. So what is it asking? What is the minimum possible value of y? Is y can be 420, or it has to be greater. So y can only have a minimum of 420, right? It can be 420 or 421, 422, 423, if you assume they're all integers. So the lowest it can have would be 420. That's what is implied by the equal sign here, and that is the correct value. So 11 and 12, they're easy, but they may take a little more time than you might think. So 11, first we have to simplify this expression before you can solve for x minus 1. That's always the case. Negative 6 less than or equal to 3 minus 2x less than or equal to 9. Greater than or equal to minus 6 less than or equal to 3 minus 2x, which is less than or equal to 9. So what you could do is, we could subtract negative 3 on both sides, right? So which would give you negative 6 minus negative 3, negative 2x less than 9, right? Minus 3. So this would be negative 9 less than or equal to negative 2x less than or equal to 6. Now divide by negative 2, right? So that would give you negative 9 over 2, right? Less than or equal to x less than or equal to 3, right? Right? And just basically divided by, oh, this would be the negative 3, right? Right? Now, but the question is asking x minus 1. So if you subtract negative 1 on both sides, then it will be 9 over 2 minus 1 less than or equal to x minus 1 less than or equal to -3, -4, right? So it will be 7 over 2 less than or equal to x minus 1 less than or equal to -4. It's asking what is the greatest possible value. That means the greatest. -4 is a smaller number. X minus 1 equals -4 is small. X minus 1 equals 7 over 2 is the largest value you can have. So the answer is 7 over 2. I hope I have enough space for problem 12. All right, problem 12 is very conventional. So let's solve each one separately. So 4x minus 2 is greater than 17. So let's add plus 2 on both sides, which would make it 19. X is, you divide by 4. So x is greater than 19 over 4. We can simplify that at a later time. Let's go ahead and solve the second portion. 3x plus 5 less than 24. Let's subtract -5 on both sides, which is 19. X is less than, you divide by 3 on both sides, x is less than 19 by 3. So because these are two different values, let's do 19 over 4. So that's 4.75. So x is greater than 4.75 and x is less than 19 over 3 is 6.3, right? So x can have 4.75 greater than x is less than 6.3. So x can have integers, means there's only one integer left between 4.75 and 6.3, right? That's 5. So x equals 5. Keep in mind the question is asking for an integer value. So x is 5. So if you got 10 out, if you got 12 out of 12 on this test, then you definitely have a strong grip on the concept of inequalities, both from just inequality perspective or inequality and graphing combined together, right? So thank you for watching, and I wish you all the best on your SAT math exam. Continue watching for content on my channel. If you haven't subscribed, consider subscribing to my channel and stay tuned for more content on SAT mathematics. I'll see you soon. Bye-bye.